All right, so this video is going to be homework hints for chapter 7, which is on sampling distributions. The first section, we are going to work on question 7.6. And I wanted to choose this question to go over, even though it's just here at the beginning, because I think the wording might be a little bit confusing and I want to make sure we know what we need to do to answer this question. So in the problem, it gives the ages of 6 members of a family and X is the age, and it says to write the probability distribution. So X is the age, and I'll go ahead and write this down: 15, 21, 25, 28, 53, and 55. And then since they are all equally likely of being chosen, you want to think about if n is 6, they would have the same probability of being chosen here. And so that's going to be the probability distribution you're going to create in part A. In part B, it says that we want to choose samples of size 4. So our sample size is 4, and it wants us to go through and think about how many people can, how many ways can we select these people. Well, if we have 6 and you're choosing 4, you're going to use that combinations. 6, choose 4. To know that there's 15 different ways that we could choose 4 people from this family of 6. And then it wants you to list them out. So like, for example, the first sample might be the first 4 people. The second sample might be the person that's 53 instead of 28, and so on and so forth. You're gonna have 15 of these. Then in this problem, you're going to want to find the mean. Okay, so it's a little bit tedious. You could use Excel if you wanted to. You're going to find the mean, and then you're going to think again about what's the probability distribution of this information here. And remember, there's 15 outcomes, and just like there were 6 outcomes in part A, that should help you figure out part B. And then on part C, it says calculate the mean of the population data. So you'll find the mean of this right here. And then it wants you to compare that with one of the outputs to find the error. And just remember, our error equation is x bar minus mu. So you can really choose any of them here for that. 7.6 took me the longest to go through and do all the things on. It's kind of an intense problem for the first problem of the homework set. So that's why in the video, definitely wanted to go over just kind of the expectations of that problem and what some of that vocabulary meant. In section 7.2, I'm going to have us look at problem 7.14, okay? And it says, living spaces of all homes in a city have a mean of 2,300 square feet and a standard deviation of 500 square feet. So since this is all homes, I know that that's a population mean of 2,300 square feet and a population standard deviation of 500. It then says, let X bar be the mean living space for a random sample of 25 homes selected from this city. So N is 25 here, and it wants to know the mean and standard deviation of X bar. So X bar's distribution is going to have a mean that is exactly the same as the population mean, and it's going to have a standard deviation that's the population standard deviation divided by the square root of n. And here's kind of some rationale as to why that is. So if this is X, okay, and this is all homes, here's 2,300. I'm choosing 25 homes from this population, and it's going to be a lot of them here in the middle and not as many out here, just because of how probability works, right? Like if there's more likely a chance to get a random home that's in this range than out here. And then after I find that sample of 25, I find the mean, just like we did in that first question that you're gonna do, and you're gonna plot whatever that sample mean is. And then you're gonna do it again and choose another random sample of 25, and then plot that sample mean, and so on and so forth, and so on and so forth. And you actually are gonna get a new distribution. It's a distribution of the sample means that's going to be centered with the exact same mean of 2,300, but the spread's going to be a little bit smaller by a factor of square root of n, because you're taking the average of those data points, and those averages are going to be centered closer and closer and closer to 2,300. And again, this is central limit theorem. It's a theorem that is super commonly used in statistics, and that's just kind of why the standard deviation changes when we're thinking about the distribution of the sample means versus the distribution of the entire population here. All right, on 7.3, 7.3 is some kind of application questions here. And so on 7.3, we can look at 724. Okay, so the problem stem on 724 says the amounts of electricity bills for all households in a particular city have an approximate normal distribution with a mean of 140 and a standard deviation of 300. So our population is normal with a mean of 140 and a standard deviation of 300. And I'm not sure if Professor W uses this type of notation. This is just kind of shorthand for labeling your distribution here. So normal distribution, big N, mean, standard deviation in parentheses like that. And that's our population here. Let X bar be the mean GPA of a random sample of 48 students. So my sample size is 48. Find the mean standard deviation of X bar, and then comment on the shape. Well, if your population is normal, every sampling distribution you take from a normal population, every sampling distribution is also going to be normal. The mean of that sampling distribution is centered at the exact same mean as your population. And just like the one we did up here, we're going to do 30 over the square root of n for our standard deviation here. And so that notation allows you to communicate center, shape, and spread of a distribution really quickly and really easily. Just that normal, here's the mean, here's the standard deviation for that sampling distribution we're talking about. All right, 7.4 has us now applying these theorems and actually finding probability values here. So on 7.4, I'm going to have us look at problem 7.36. Okay. On 736, it says the times that college students spend studying per week have a distribution that is skewed to the right. So the distribution of study times is skewed to the right with a mean of 8.4 hours and a standard deviation of 2.7. And the reason it's skewed to the right is that mean, okay, is 8.4, but there are going to be a few students that study a lot more than just that regular like 3 standard deviations away from the mean. And then we also have like that zero, like you can't have negative time, right? So it makes sense that this population distribution is skewed to the right. It is not normal. This is skewed right. Find the probability that the mean time studying per week for a random sample of 45 students would be, and then it gives us some things here. So I'm now going to take samples of size 45 from this population. Because 45 is greater than or equal to 30, central limit theorem applies here. And since the central limit theorem applies, I know that that distribution of sample means is approximately normal. The mean of that sampling distribution is centered at the exact same mean, and the standard deviation is 2.7 divided by the square root of n. And in this problem, it ends up being 0.4025. I'm going to use this to then answer questions because it wants to know what's the probability that I take the sample of 45 and that the sample mean is these values in this problem. Okay, so for example, in part A, it says what's the probability that sample mean is between 8 and 9. Okay, so the probability that I take that random sample of 45 and I take the mean of it, and that mean is between 8 and 9. So I like to draw my x-bar distribution, just like I would have done back like in chapter 6. Okay, my mean is 8.4. I know that 8 is on this side of 8.4 and 9 is on this side of 8.4. And so the probability I'm looking for is this right here. Now, if you know the normal CDF notation, you can go ahead and do that now. I am going to walk through kind of like how to find this the long way with the book, okay? So that if you don't have that calculator, you're still getting that support. So you need to find two z-scores because we have two x values. So the z for 8 is x minus the mean all over the standard deviation of the sampling distribution. I'm going to do that same formula for 9 to find the two z-scores. I know that this z-score is going to be negative. In fact, it's negative 0.99. And I know that this z-score is going to be positive because of where 8 and 9 are located on this distribution compared to the mean. 8 is smaller, so the z-score has to be negative. 9 is bigger than the mean, so the z-score has to be positive. And then remember, if you're going to use the back of the book, you're going to find this p-value first and then this one and subtract them. Or you can plug these into normal CDF, but from here you'll then find that p-value here. The other part of the question says, what's the probability that that sample mean is less than or equal to 8? So again, I'm going to look at my distribution of x bar values, 8.4, 8 would be down here, and this is the probability that I want to find. I already have that z-score calculation from the first part of this question. I now just want to go find that left-tailed probability, and you can do that again in the calculator or in the chart, but that's how you're going to find those probabilities of those sampling distributions there. All right, the last two sections have to deal with sampling distributions of proportions, and so the question that I want to go over first is question 7.52. So 7.5 is the section and 7.52 is the question here that we're going to look at. Okay, and so it says in the problem, a population of size n, which is 1,400, has a population proportion equal to 0.47. I use capital P when I'm talking about population proportions, just so that like when I'm taking these problems, I'm realizing like this is the population that I'm talking about. Okay, and so it tells us to calculate the p hat value for each one of the n's. So what would be the sigma, the standard deviation for 90, and what would be the standard deviation for 50. And so if I'm talking about a proportion here, then the standard deviation equation is PQ over N, and then you take the square root. So square root here of 0.47, Q is found by doing 1 minus your probability, and then you're going to divide this by N. Now, similarly, you're going to do that exact same equation here for 50, just plug in N equals 50. Similarly, though, for central limit theorem, like what's happening here is if this is our entire population, like this is the 1400, and our center is at 47%. As you're taking these samples, you're taking that 90, right? This is going to now be that sample standard deviation here, okay? And so it's going to be the similar like central limit theorem type problems. It's just this is how we're going to calculate when we have proportions. A proportion that is 4 or is the variable, and then the complement is what you do for the Q value here. And we're going to use that to find probabilities like on in 7.6. So if we look at 7.6, questions here. 7.6, let's do question 7.66. Okay. And this will be the last question that we do in our video here. So there's some batteries that are being made. The company claims that 80% of its batteries are good for 70 months or longer. P hat is the proportion in a sample of 100 that are actually good. So in the problem, it tells us that the population proportion should be 80%, and then it gives us our sample number here. So because I'm going to be asking or answering questions about sample proportions, I need to know what the distribution is of P hat. So P hat is going to be normally distributed. Now, the mean of that distribution is going to be centered at the population proportion. And the standard deviation of that distribution is going to be at P times Q, which is 1 minus P, all over N. And it turns out that gives us 0.04 here. So then on part A, it wants us to find what's the probability that the sample proportion is within 5% of the population proportion. Well, if our population proportion is 80%, then within 5% of that would be between 0.75 and 0.85. That's the proportion that we'd want here. Now you're gonna find your Z and all of your calculations for the p-value exactly the same way. You're just gonna use your sampling distribution for that calculation. So your first Z-score is gonna be 0.75 minus 0.8 over the sampling distribution standard deviation. Your second Z-score, 0.85 minus 0.8 over this standard deviation here. Okay, you end up getting the exact same Z-score, one positive, one negative. And when that happens, that should make sense because the distance between the endpoints and the mean are the exact same. So they should be the same relative z-score distance from the center of the distribution. And then you should be able to find the p-value from there. On part B, it says, what's the probability that a sample proportion is less than the population proportion by 6% or more? And I found that this question, like the wording of it, was really, really confusing because it says or more, but you have to be really careful. Okay, so that it's less than 80% by 6% or more. So I'm going to go to 0.74 because that would be my 6% below. And then it needs to be at that percent or more or less than it, which I thought was really an interesting way to ask this question, but that's what we're looking for. Same process here, find a z-score, mean standard deviation. And then C is 0.8. What's the probability that the sample proportion is greater than the proportion by 7% or more? So now I'm up here at 0.87, and I want to find this tail probability right there. All right, I hope that you found this helpful in completing your homework for Chapter 7.